Hello everyone, today we're going to be talking about motion in one dimension, and this is one of the most important topics in this chapter, so let's start. Now, we said before that an object can either move with zero acceleration, that means it has a constant speed, or it can move with a constant acceleration where the acceleration does not change, and it can move with a variable acceleration, and this is not our topic. We are not discussing variable acceleration. We are going to go in detail with constant acceleration. So, if an object is moving in a constant acceleration, we already introduced an equation that says that the acceleration is the change of velocity divided by the change of time. And from that we can derive some equations which are famous by the motion equations or the equations of motion. Now, remember one more time that these equations are used when we have a constant acceleration. But if we have a zero acceleration, the equation is going to be more simple than that. It's what we introduced before. Speed is distance over time, and velocity is displacement over time. But if we have acceleration, the equations I just mentioned right now do not work. We are assuming that the object can move either horizontally or vertically. So when an object is moving horizontally, we have these four governing equations. The first equation says that the v final x means the final velocity in the x direction. It's equal to vix, which is the initial velocity in the x direction, plus at. A is the acceleration and t is the time. For the second equation, v final x squared, which is the final velocity in the x direction, squared, is equal to the v initial x squared, which is the initial velocity in the x direction, squared, plus 2 multiplied by a multiplied by delta x. A is the acceleration, which is clear for now. Delta x this time is the displacement. Why did we change it from delta d to delta x? Well, because we are moving horizontally. It's more famous to use the term delta x. So when you see the term delta x, that means you're talking about displacement, okay? Again, there's another equation. Delta x is equal to v initial x, initial velocity in the x direction, multiplied by t, which is for time, plus half at squared. And finally, there's another equation for delta x, which is half multiplied by, open a parenthesis, v initial x plus v final x multiplied by t. Actually, all those equations are derived from this equation. How did we do that? Remember that delta v is equal to v final minus v initial, and delta t is also equal to t final minus t initial. If we arrange these equations, we can arrange them in more than one way to get these equations. Now, if an object is moving vertically with a constant acceleration, how can an object move vertically in a constant acceleration? When I speak vertically, we're talking about, for example, a free fall, an object falling vertically. But how is the constant acceleration present in these equations? Well, remember that Earth has a constant gravity acceleration, which is equal to 9.8 meters per second squared. So, in these equations, or when an object is moving vertically, and when we say vertically, we are mentioning free fall equations, the equations are almost similar, but instead of a, we are replacing a each time with negative g, okay? Each time we are replacing a with negative g. So actually you don't have to memorize the equations for object moving vertically. You can just replace the a here with a negative g, okay? So as we mentioned, we do not have to memorize the equations again. Okay. Now, this looks kind of cumbersome at the beginning, but if you follow the steps I'm going to show you, by the end of this video, you will have no problem solving no question, no matter how difficult it was. Just follow the steps. It's easy, but it needs a lot of practice. Practice is the key in this type of questions. Now, to do it, we're going to do the following. First of all, we're going to read the question carefully and extract the given information. Now, sometimes there's a small trick. Sometimes some of the information is not mentioned clearly, but there's a hint in the question giving you some information. How are we going to know, is there a hint, or is the question, or is the input really there? Well, that comes with practice. So by practicing, we will look at most of the hints. Now, the second step, we will write down the motion equations. Every time, yes, every time. I really encourage you to write the equations of motion. Every time you solve a question, Why is that? Because you will reach a point that you will memorize them without forgetting them. Second of all, you will reach to a point that you won't have to write them every time. You will just know which equation you will use because you have them in your mind. You can just use the equations in your mind without even writing them down. So at the beginning, I encourage you to write the equations of motion every time, okay? After that, we will solve the equation that has only one unknown. So we write down the equations and we look for the equation that has only one unknown, because we can't solve a problem that has more than one unknown, or we can't solve an equation, sorry, that has more than one unknown. Now for step number 3, you will go to the next equation that has only one unknown and solve it. Keep repeating this step until you get all the unknowns requested in the question. Talking is easy. Let's try an example on how we can do these steps with an easy question. The question says, a bicycle starts from rest and accelerates at a rate of 2 meters per second square. How far will it travel in 10 seconds? So let's start with extracting information. A bicycle starts from rest and accelerates at a rate of 2 meters per second square. So it's clear that we have an acceleration equal to 2 meters per second square. How far will it travel? So the unknown is the distance, or the delta x. So delta x is unknown in our case. And how far will it travel in 10 seconds? So we have the time is equal to 10 seconds. Now, some of you may think that we have extracted all the information from the question. Well, actually, no. There's a hidden piece of information that you must get used to. It says that the bicycle starts from rest. When something starts from rest, means that it had a velocity equal to 0. And since it mentioned that it started from rest, this means that v initial x is equal to 0. Okay? So now we've extracted all the information. One of the information was hidden. Now we found it. Let's see what we can do. Again, we extracted the information. Remember that it starts from rest. A is equal to 2 meters per second square and t is equal to 10. It's asking us to find delta x. Okay. Second step. We're going to write the equations of motion. We are going to write all the equations of motion, and let's start with the first equation. Remember, this is the input that we got from the question. Equation number 1 says that v final x is equal to v initial x plus a multiplied by t. Now, what do I have from these? Do I have v final x? No. Do I have v initial x? Yes. Do I have a? Yes. Do I have t? Yes. So I can use this equation, okay? Let's go to the second equation. V final x squared is equal to v initial x squared plus t a delta x. So I have, in this equation, there will be two unknowns, which is v final x and delta x. So can I solve it? No, it's not solvable. So two unknowns, we cannot start with this equation. Delta x is equal to v initial xt plus half at squared. Can we start with this equation? Yes, we can, because there's only one unknown. And finally, the fourth equation, we cannot solve it because we do not have v final x. Therefore, we have two unknowns. So now we have two equations that can be solved directly and two that cannot be solved directly. What should we do? Well, from step 2, we saw that equations 1 and 3 can be solved. Here are the equations. Equation 1 and 3 can be solved, but it's obvious that the question is asking for the distance traveled, delta x. So we will start with equation number 3. So delta x is equal to v initial xt plus half at squared. So we're going with this equation right here. We'll just plug in the numbers. Delta x is equal to unknown, we don't know it. V initial x is 0 plus or multiplied by t, which is equal to 10, but 0 multiplied by 10 is 0 anyways, plus half multiplied by the acceleration, which is 2, multiplied by the time squared, and we will get the answer is equal to 100 meters. So this was a very easy and straightforward question. Stay tuned. In the next videos, we will be solving many questions with many examples and ideas. See you then.